we have studied most extensively one framework, it is called Java collection framework. Parallel to this Java collection framework, there is one very important framework also known, it is called the MAP framework. MAP framework basically is to serve one data structure, it is called the table. Now, table is a very common one form of data, and particularly in most of the IT applications the table is there. So, a collection of tables, it is basically form what is called a database. So, today our target is to cover this is very common but extensively used data structure, it is called the table, and the MAP framework in Java which basically supports all activities those are related to table structure. So, basically we will try to discuss about how the Java concept, that is the MAP concept actually, that is used to store tables and manipulate tables, and behind this manipulation one important concept is known, it is called the hash function. So, we will try to learn about hashing or hash function, and then the MAP framework utility which is defined in java.util package will be discussed in details. So, this is basically our plan. Now, let us see what is the problem or other issues so far storing data is concerned, and how these issues can be addressed with the concept of what we are going to learn today, it is called the mapping. So, I will try to give one idea about this concept of this storing data. Now, consider there is a table. So, a table is basically is a collection of records. So, we can say there is a number of rows. So, each rows is basically is a record. For example, there are say large number of students whose data needs to be stored in a database. So, we can say a table can be planned for that, where each record corresponding to a student's data. So, this record is also in our concept of object oriented programming, it is called objects. So, a student object we can say. Now, as you know, each record is defined by a number of attributes. So, these basically constitute is called the columns. So, there are maybe any number of columns are there. So, these columns basically in the context of object, it is basically called a field. So, an instance of a student's class which basically constitute a record, and there is a field which can be considered as a unique, there may be more than one fields also, by which each record can be uniquely identified. So, such a field, it is called a primary field, or we can say primary key. Now, so this is the field K is the primary field, and these are the many objects we can say. So, this is basically the third object. So, it is an object O. So, a table is nothing but a collection of objects, and each object is identified by a field, or it is called a key, that is called the primary key. Now, so this is basically storing a table in a database, which is the common concept. Now, what is the problem? Let us see. Suppose we want to modify a record for a given student. So, what we have to do? We have to reach to the row where that student's record is available. So, how we can reach? So, we have to search the table, and then if record is found, then that record can be read, and then whatever the modification is required, we can do it. So, searching is a very common what is called the operations which is required in case of handling table. Now, you see the searching can be done in many different ways. So, a trivial searching procedure is basically starting from the first record and compare the key of that record, which basically our target record, and go on until we find the record, or we can reach at the end of the table. But this process, you know, it is easy, simple, although, but it is not an efficient, particularly when the large number of records are stored in the table. So, what is the procedure? We need some mechanism by which the searching time can be minimized, because in a table there is a huge number of records accessing is required. So, each time searching takes enough time, then definitely it will degrade the performance of the system. So, what is called the indexing mechanism is required. Now, towards this direction, I mean indexing, we can apply binary search tree, which we have already studied. Binary search tree is basically an important data structure for the purpose. What binary search tree does for us so far the indexing is concerned? It is very simple. You know, in case of binary search tree, there is a number of nodes, and all the nodes are arranged in a particular order, is basically satisfying the binary search tree property. Now, here each node basically store the key value of a record. So, K1, K2, key value of record. So, K3, whatever it is, you can see. K4 and so on. So, the number of nodes is basically in the binary search tree is same as the number of records in this table. Now, K1 is basically, you know, if we want to search a particular record having a particular key, that is when the primary key, then we can take the confidence of this binary search tree to go fast. Now for each key, it also store one additional information, the information regarding actually which is the memory location where that particular record, whose key value is stored in the node. So, this means that each node store not only the key values, but in addition to a pointer to which record it is stored there. So, it basically store a pointer. So, suppose this is the pointer which is basically pointing of a record whose key value is key 5, and it is like this and so on. So, this pointer is there. And like this. So, this binary search tree not only store the key values, but also store the pointers. Say suppose you want to access a particular record whose key value is K3, we can just take where is the K3 is there, come here and then go to the record, so we can go it. Now, what is the advantage? Advantage is that the earlier searching, which was simple and trivial, it took order of n time. That means n number of comparison that is required in order to find a particular record. On the other hand, if we take the binary search tree, then it will take order of log n time, and since this order of log n is less than order of n, so we can say that this procedure is far faster than this procedure, that is the trivial linear searching. Now, here basically you can see we have followed certain concept of indexing, or there is a mapping. There is, and so this basically the mapping that we have discussed, but there is another mapping. This mapping is far better than both order of log n or order of n. What is the mapping? The mapping is that there is a function, let this function be h, this function is called hash function, and if the target key say k, that is we want to find a record having the k, so let ki, the ith record we want to find. Now, this h function is planned in such a way that if we give the ki value, then this hki will give the address where this record having the key ki is stored. So, this basically tell that where this O is stored. So, using this we will be able to directly go to this one. Now, this is the one called hashing technique, by which we can do it far better, because this takes order of constant time. It is independent of n, whatever be the size of the tables, it is absolutely independent of that, and therefore, this is far better than this one. So, the concept is here is called the one hashing concept, that is we can use it. So, now today we will discuss about this concept of hashing in our study, and then in order to manipulate the table. So, storing data with mapping is basically using the hashing concept that we are going to learn. So, let us start about the concept of what is called the hashing concept. It is there. Now, as you see here, so in case of hashing technique, there is a two things are to be are involved. One is that for each object, and there is an association with a key value. So, key object pairs are there, and then key obviously should be unique. That means there should not be two objects for which the key value are same. That means two different objects, if they are there, then they should have the different key values are there. So, it is basically very good for fast searching, and each key is basically maps an object, and this mapping can be obtained by a mapping formula. It is called the hashing concept is there. So, that is what the concept is, that for every object OI there is a key KY, and therefore, each object is mapped by means of KI. Now, that why this mapping is possible? This mapping is possible by means of a h function. It is called the hash function. Now, this mapping, if you see, it is very similar to the function, for example, y equals to fx function. So, what is the thing? Thing means that where x is basically dependent, x is y is basically independent, x is basically is a independent variable, and y is the dependent variable. So, for a given value of x, there is a value of y. It is not true that for a given value of x, there are two values of y. It is not the property of function, but for two different values of x, there may be same values of y. It is possible in case of mapping. Anyway, so this is the usual concept of mapping that is known in mathematics. So, here mapping means this is the set, if this is the set x and this is the set y, is basically, and this mapping is the function fx, means how the x can be related to y and vice versa, it is there. So, this mapping is basically the concept behind the hashing technique that we are going to use for our database or table manipulation. Now, so we have learned about the mapping. Mapping has extensively used many application in our usual concept of file structure, that is used in computer memory. There is every file name has association to a file object actually which is stored in memory. So, there is a mapping from the file name to files which is stored in hard disk or secondary storage, and like this the mapping is everywhere. For every error code there is a corresponding error mechanism routine, for every country or every location there is a pin code. So, there is a mapping from location versus pin code, and like. So, there are many examples of mapping which we basically are familiar to. Now, this concept of mapping is very useful to help us in indexing a table. So, is basically mapping is useful for fast retrieval of any object, where object basically represents a record, and entry is characterized with pair of elements in our mapping mechanism, as we have already mentioned about the record itself and the key value, and the mapping is basically by virtue of this mapping mechanism or hashing technique is there. And as I told you, the key must be unique, as you know, in case of binary search, and that is what we have assumed, that there is a field for every record for which each record have the distinguishable or discriminable by that key value or field. So, that is why it is unique. and so duplicate key it is possible, but we should not include that duplicate key is there. Okay, so a map should not contain any duplicate keys in that sense. So mathematically the mapping which we are going to use is basically one to one and onto mapping, it is called the association. Now let us come to the concept of hashing as a mapping function. Now so it is basically, as I told you, in case of hash function, so there is any, for any object there are two pairs k and o. So this basically, if hash function is there, so hk, then it tell that which is the object it is basically, so this concept is there. So there is a hashing technique is for this purpose only. Now let us come to some examples so that we can understand about this hashing function better. Now I gave an example of a simple hashing function. Here is the hashing function. Let this hash function is defined like this. So you know, modulo remainder operation for any integer k, assuming that k is an integer, so it gives you, here is some example as we can see. So h123, if we apply this module function, it will give 5. So hk equals to 5 in this case. For another example, h99, this gives you 4, and this one. So these are basically, we can say, address of memory where the object whose key value k is stored. So it is an object whose key value is 123. It is another object whose key value is 99. It is another object is key value is 2014. Now here judiciously you have to decide this key value so that any collision, if it is there, it is avoidable or it can be avoided. So collision, if it is there, it should not be, well, it is not desirable. For example, I can say suppose h and 24. So this is also equals to 5. That means if there is another object whose key value is 24, then it basically gives the same mapping or memory location. That means the two objects whose key value is 123 and 24 are located in the same memory location, which is not possible, which is not desirable. So hashing mapping or hashing function should be chosen in such a way that for every object there is a memory location it will return is basically unique, and that is the only problem which basically needs to be handled very carefully. So this is also a very simple example, but this kind of examples may not work always. So you have to take care about this kind of problem, and that is the only issue that we have to think about how this can be solved there. Now in order to resolve these issues, there is a concept. This concept is called hash code. Hash code is one method which is defined in the object class. The class object is a superclass of all objects which is defined in java.lang package. This means that any objects that you define basically is a child of the parent class of objects. So all objects that you define by any class declaration, like say student, person, employee, whatever it is, they are basically the child class of objects. So hash code is defined in the object which is the default method, and so as any object is a child class of object, so by virtue of inheritance this hash code method is also available to this one. Now so this hash code basically gives an integer value, maybe long value. It basically essentially a memory address where a particular object is stored. So this hash code therefore is a very clever solution that is defined by Java developer, which basically if you give a key value for any objects or set of key values to this hash function, then it will calculate a unique address for that object. And however, you can also override the hash code method in your class declaration. We will see exactly how such a overriding of method is possible, or overriding the hash code. That means you can define your own hash code also, and usually that is more desirable for the programming point of view. Now let us consider an example for this. So, here x and h are the two integer variables declared. Suppose x is 555, then here h and then hash code, if we call for this integer, it basically return what is the hash value. So, it basically it will return for some mechanism it is there, which mechanism, that is basically very okay, it is internal to the Java development. We should not think about how they convert an integer value to hash value. So, this hash value it will return. You can write the program and you can call this method for any variable or any objects and you can find it. Now, here double y, and if you call the hash code for this y, it will basically give a unique value corresponding to the hash code of y. So, it is basically just hx, hy, the hash mapping we can say. Now, for a given string also, this is the hash code. So, usually we use the password or login ID. So, computer convert those password or login ID into hash code, and that hash code is basically a one way function. Given the hash code, it is very difficult to come back to the original. For example, so this is the string for which the hash code that h will return, and from this given you will not be able to come to the what is the original input string for which the hash code is h. Now, as another example, let us consider this. So, s is an object of class student. Now, s dot hash code we can obtain what is the hash code of this object s, but this is possible if we define our own hash code for this object. Otherwise, call this code is basically sometimes give you compile time error, and it is avoidable because it will try to give the default hash code, which is basically compile time does not accept it. So, here basically you need to define your own hash code for the newly defined class S, for example here. Now, let us see how such a hash code can be overridden, and there is a program. You can consider this program for an example. This program is basically declare a class. The name of the class is person. It has three fields. The one is first name, last name and age, and here is a constructor of this class to initialize objects, and here basically we are overriding hash code. How we are overriding hash code, and this is the one method that we have decided. Okay, how we have decided, it is up to the programmer's ability. So, here we decide that what is the hash code of string first name multiplied by 5 plus the hash code of string last name multiplied by 7 plus the hash code of integer age multiplied by 11, and then it will return a very complex one numbers which basically consider the hash code of a particular object which basically we creates. So, if for example, here an object is created say p, and having these are the different values for the objects, and then it will return the hash code k for this object, and you can print this hash code. If you print this hash code, usually you can see it is in a hexadecimal string that it can return. So, this way we can define the hash code of our own. Now, here is basically is the intelligent aptitude that needs to be applied, how we can define hash code for all objects which should be unique for every object that you have to deal with. Now, so there are certain theory behind it. Those theory I want to skip. If you are interested, you can search many literature regarding hash code generation. You can find many ideas from there. So, there is not a single idea, rather many ideas to generate the hash code, it is there. So, we have learned about the concept of hashing and hash code generation, and how this hash code basically gives a unique representation for a given key value of an object, where key value can be only a single attributes or it can be multiple attributes, as we have learned in the last examples, where first name, last name and age are considered as an attributes to generate the objects. So, whatever it is, not an issue. So, key value is not necessarily that a single value, it can be a composite value, what I want to mention categorically. Now, let us come to the concept of, so these are the things that we have discussed about from the theoretical point of view in the conceptual level, but many things are made easy what the Java developer has done for their programmers, so that we can have it. So, that is the map framework for which we can have all those things automatically. We do not have to bother about how this has code, how it can be generated, how it can be used, and whatever it is there. Now, let us see what is the map support which is there in the Java framework. Now, Java consists of two frameworks, the collection framework and map framework. Map framework is basically to deal with these tables or mapping that is there. Now, the map framework, if we see the class hierarchy that is there, it has this class hierarchy. There are number of interfaces defined in this framework. The interfaces are mentioned here, namely map, sorted map, and then navigable map. Those are the interfaces which basically have the design. Any class you can design if you want to implement a particular interface. So, interface has the declaration of all methods or fields or any constant in them. There is no method defined there. Now, so there are certain methods which basically you can use in your program to create the objects in order to manipulate your tables by means of your mapping mechanism. Now important, the classes which basically we consider are there. Now, there are two classes. These two classes are basically for the Java developers use only. So, we will not consider all those things in there. Now, so there are four classes. One is called enum map, hash map, linked hash map, and tree map. This basically, this class allow you to create a collection. This collection is basically a table, and automatically the indexing and everything will be taken care by this. Now, using these classes you can create objects, and for this object you can call many methods how to add new object into this table, how to remove, how to access, how to search. So many operations, those are usually required for the fastest access from the table. Now, here again enum map is basically extends the abstract map. Abstract map is the abstract class actually. The hash map is also extend the abstract map. Linked hash map is basically extend the hash map, and tree map again extend the abstract map. So, this means that again you see abstract maps basically implements map, and then sorted map is basically extends the map, and navigable map again extend the sort map. So, all methods which are defined in map is basically by means of inheritance also included there. In addition to their methods in map, they have their own method defined in sorted map and everything. All the methods which are defined in these interface are implemented in all these classes. So, all these classes are implements all the methods which are there. So, in our subsequent few slides, we will try to understand about what are the interface compositions, what are the methods are there, so that we can use them in our program. Regarding programming using map, we will discuss in the next video lectures. Today, we will just have the familiarity about the composition of this map interfaces and map classes. It is too much also, but I will try to give a brief summary about all those things, so that we can have a quick look about this. Now, let us have the map interfaces. We have told you that there are three map interfaces. One is map, another is sorted map, and another is the navigable map. In addition to this, there is also another inner class is defined. It is called the map.entry, which is within the map interface. It is there. So, all these map interface is basically is a generic what is called the type. The type is of K and V, where K is all generic type and V is of any type. So, K can be any type, V can be any type, and V can be any type of object, K can be any type of object. It is the concept, it is there. So, it is a pair. Now, there are so these are the different interfaces that we have discussed. In addition to the interfaces, there are many classes, as we have already mentioned. These are the important classes which are basically used in programming, namely enum map, the hash map, linked hash map, and then tree map. Now, let us have a quick tour to all interfaces. That means, we will try to give a summary of what are the different methods are defined there, and those methods are ultimately defined in the classes, namely enum map, hash map, linked hash map, tree map, etc. So, we will just for familiarity we will see what are the different methods are there. A details discussion of the method it is beyond the scope of this lecture, and for the detailed discussion I should recommend you to check the Oracle websites. That is the document where the detailed documentation of each interfaces with examples are available. So, there are many methods as we see here. The compute method is basically how a key, for a given key, the hash value can be computed, and is a compute if absent. There is a if present function, and then contents key, that means whether a key is available in the collection or not. So, those are the methods are there. Now, there are few more methods also, it is defined there. Here also I have included here contents value. It is basically if a particular object is present in the table or not, equals whether two objects are same or not. For is basically for the traversals. Here get is a very important. Get means you have to access an elements. So, get method have the two different version. That means given a k, whether how we can get the object from the table, and then hash code is the default method. It is basically there which basically return the hash code, and whether the collection is empty or not, that needs to be checked. So, these are the different method by which we can simply know about the collection. A collection is, in this case, is a table. So, there are so many methods which are defined there. Here the put if absent, the get method is basically to access it, put is basically to store it. So, there is a different methods, and then put version is there, and remove is basically to delete. So, there are many remove method is there. Replace is basically modification, that means if you want to modify certain key values or objects. Replace all if you want to modify all, and then size basically what is the size of the tables, and then values is basically all elements in the tables can be obtained using this method. Now, we will learn about the use of these methods when we will discuss the programming. So, mainly so far the programming is concerned, these are the methods we have to learn little bit sincerely, so that we can understand about it. When we will go for programming, then we will discuss about all these methods in details. The get and put method, and then entry set, basically it will basically give you the set form of the collection or tables. Key set is basically set of all keys, those are there in the table, and values basically all elements, those are there in the tables, means all records we can say. So, these are the important methods basically we shall use in our programming, or any programmer should use all those methods in their programming practice. Now, so like this map interface, there is sorted map interface also similar to the interface. There are many methods which are declared there. For example, comparator, head map, this is the first elements, the last element, then sub map, subset of the table, tail map, the last few elements of the table given the starting values of key. So many things are there, and here sorted map is basically the difference between the map is that in case of map all the tables objects are not necessarily in sorted order, but in case of sorted map it is basically sorted as per the key values of each objects. So, this is the sorted map, and navigable map is basically the idea about the closest key value. If it is given there, if it does not match perfectly, then it will try to find the record or objects which has the closest match. So, that is why the navigable map has been implemented there, and it has many methods. There is basically ceiling entry, that means it is some key values which is greater than some key value which is basically ceiling key, ceiling entry, and descending key set, that means it will give the set of values in descending order. Descending map, it is all objects in descending order. First entry, which is the first object, it is there. There are few more methods also it is there, like that floor entry, as it is opposite to the ceiling entry, below to a certain values the key, and then floor key is all the objects, all the key values, basically certain value which is basically decided by the object that is there, means below objects, or it is basically lower bound upper bound like. So, there is also head map giving the upper bound, and then boolean, that means whether we will include all or not, then higher entry, hierarchy. So, those are the methods basically we will discuss whenever we discuss programming in details, illustrating how these methods work, and then we will be able to understand, but it is for the summary only. These are the methods available for you, so that you can use it. And there is so in these are the different methods, and likewise the map classes are there. The map classes are ultimately that you can create an object, that is the collection object in your program, and then it basically you can manipulate this program. And again I repeat, a collection according to this map is just a table. A collection according to this Java collection framework that we have discussed about, vector is a collection, array is a collection, array list is a collection, tree is a collection, linked list is a collection, those are the different collections that we have discussed. But here all these map basically gives a new form of collection. This is called the tables actually, and the table collection is characterized two sets. On the other hand, all these collections are characterized only one type, generic type, right. So that is the difference. And now so far this map classes is concerned. So how a map classes, it is also called container. How a collection, it is called, rather we can say the container, a container can be created, how container can be sorted, how some objects in a container can be retrieved, how some objects in a container can be removed, how some container can be viewed, and how the bulk operation, copy from a set to another set, all these things can be done, or a table can be copied from another table, or two tables can be merged, and so many things are there. So these are the basically activities or operations that we will be able to achieve using the different classes which is defined in the map framework, and these are called the map classes. And so far the different map classes are concerned, I have already mentioned that 4 map classes are there. So those map classes are basically enum map, the hash map, tree map, linked hash map. These two maps are not used for the programming purpose, so they are not included in our discussion. So this is basically overall the map framework. Now there are different methods. Truly the methods, those are already learned about interfaces, they have been defined all these interfaces. So there is no extra method in each classes actually to be studied further. So however, only thing that needs to be understood about that how the different collections or container objects can be created. So constructor needs to be there. So in our few in our next few slides we will try to understand about how the different constructors can be created. Okay, that will be discussed in our next video lectures, where we will discuss about the different classes and the different constructors which are basically used to create the objects, and using those objects we can manipulate different tables. Okay, thank you.